The key to understanding the chemical world is the connection between the microscopic atom and the macroscopic element. Chemistry is a division of physical science. So we have already looked at physics, now we will look at chemistry. The question is, what is chemistry? Chemistry is the study of the composition and structure of matter. All things are made up of matter. And we're going to look at the reactions that cause substances to change into other substances. The atom is the smallest unit of an element. The similarities and differences on the scale of an atom, which is the microscopic scale, correspond to similarities and differences on the macroscopic scale, which is on the scale of the elements. Z represents the atomic number. The atomic number represents the number of protons in the nucleus of an atom. A proton has a charge of +1. The proton in the nucleus makes up the majority of the mass of the atom. The chemical symbols are the abbreviations of the chemical, or the abbreviation of the element's name. Chemicals are named after either their Greek, Latin, or English name, or they can be named after the place that they were discovered, or in honor of a scientist. Atoms are neutral, meaning they have equal number of protons with a charge of +1 and electrons with a charge of -1. Neutral means that my charges, my positive and negative charges, are balanced. Atoms can lose or gain electrons, thus becoming a charged object, which is now called an ion. When we take the elements and we list them in order of increasing atomic number, which is also the order of increasing atomic mass, we notice some similar properties begin to reoccur in a periodic fashion. By ordering the elements in this way, we now have our periodic table. Bohr's model of the atom links the electron's behavior, which is looking at the microscopic scale, to the behavior of the elements ordered in the periodic table, or the macroscopic scale. The model is explaining why I get this periodic recurrence of similarities amongst my elements due to the electron's behavior. So this model says that electrons occupy what we call orbitals. And these orbitals are specified with n. This n is representative of the orbital's quantum number. Each orbit will have a fixed number of electrons that can occupy that particular shell or orbital, and a fixed energy and a fixed radius. Each orbital will be a certain radius for that particular element. What we find is that when atoms have a full outer orbit, they are stable. Atoms without a full outer orbit are unstable and will undergo chemical reactions in an attempt to fill an outer orbit. When I look at the periodic table, what I get is the vertical columns are called families or groups. Each element in a family all have similar properties. These properties that these elements have is based on their outer electron configuration. From the table, we can also divide them between metals and nonmetals. The metals are on the left, nonmetals are on the right. The red elements, which are colored in red on this table, represent metalloids. Metals tend to lose electrons during chemical reactions, becoming ions with a plus charge, whereas nonmetals will tend to gain electrons to become an ion with a negative charge. Nonmetals will also share electrons in order to gain a full outer orbit. Some properties of metals that we are familiar with is the fact that metals are good conductors of heat and electricity, whereas nonmetals are poor conductors, or they're pretty good insulators. Metals are ductile, meaning they can be stretched into wires, whereas nonmetals are not. They're usually quite brittle. The majority of my metals are solid at room temperature, except for mercury. Nonmetals can either be solid, liquid, or gases at room temperature. And again, metals will lose electrons to form positive ions, whereas nonmetals will gain electrons to form negative ions, or they will share electrons. This outer orbital, or this outer shell, is referred to as the valence shell. The electrons in this shell are called valence electrons. These valence electrons are involved in chemical bonding and are very important to the chemical properties and predicting the various reactions that these molecules, these elements will undergo.